focus on some, because we will really appreciate if we focus on some certain questions or part of this PDF we are reading. We have to like work on all the calculations and everything. It's really stressful and all, sir, because we have to like try to understand every single calculation in this.
Which of for this particular question?
No, like for the cost. For the exam.
Which calculation is much, if I may ask you?
No, sir. We are talking about the old textbook, not.
What? See, there's what we call curriculum. Are you getting me?
Yes, sir.
In that curriculum, it is my duty to make sure that every aspect is covered. Are you getting me?
Yes, sir. Yes, sir.
But the calculation, if you don't understand the calculation after reading it, that is why I'm trying to do this revision for you. Because for a novice instructor, it might be difficult for you. And that is why I'm taking my time to open your PS 8110 to show you where those conditions are itemized. Are you getting it? The simplest calculation you can ever see in structure is for a simply supported beam. This is what I'm going to go over now. This particular one. That's the simplest calculation you can ever see in structure. Are you getting me? And we need to. It's impossible for me to just ask you what is column, what is beam. It is impossible for me to just ask you a simple question like that. In structures, you must calculate.
Yes. So where should we focus on?
The easiest among the calculations are what I'm just explaining to you. Because if I should go to flat beam and those thick calculations, it might be difficult for you. But I have to just explain to you the procedure. Now, when you read it, try and do some calculation based on what I've explained to you. Do you understand? The example in the notes, can you try it? Can you do it? Can you solve those things? Can you close your book and solve it again? If you're able to do that, then I think the knowledge is taken somehow. However, there's no way you will do without this particular formula, which is your K equals to M over B D squared U. It's impossible for you to do structures and using 8110 without doing this. So you understand? That is like the foundation of reinforcement in beams. And when we do the same thing applicable to slab, beam and slab, they have almost the same condition. So you just have to just know this.
Sir, please, sir. The calculations are getting too much and are getting very, very confusing for us.
Which one is too much there?
Sir, I won't lie to you, sir. If we have like an area of focus, maybe a single question that is going to come out, we will be able to calculate and digest that one, because all of these things are a lot inside our head. Bringing formulas, going to another PDF to go and check it out, coming back again, we can't really relate. We need a focus, sir. We are not structured students. We are borrowing this course. We don't understand it. I'm serious here. So, sir, please, if we can have a focus that, okay, this will focus on this, we will calculate and digest that question and we'll be able to bring something out, sir. Please, sir. Please, we don't understand this.
Hello.
Yeah.
So that you won't have problem. That is why I'm going over this for you. Because if I've given you the note already, so I've explained this for you in class already. Why I'm giving you is so that you won't have problem, so that you can see those people that missed the class, because we were about 9 in the class. That is why I'm revising this for you. It's not convenient for me. It's just a sacrifice I'm giving into class. You understand? It won't do me any good if everybody in the class will fail. So you understand? But however, as you see how I can make the course easier for you. Forget the mindset that this course is hard. It's not hard. It's very simple. It's just a procedure. That okay, if you want to design this, if you add this is how you calculate the weights. This is how you know the size you want to use, which is also applicable for what you will need on site. You cannot construct a building without having a lintel. in your building, and you cannot do without concrete. You will need to know how the weight of this concrete are being arrived at. Are you getting me? What if you go to the site and somebody is just saying, okay, provide 16 number of so diameter bar? If you don't know how to calculate it, how will you be able to vet it? How will they be able to put you as the quality assurance personnel to vet, to vet what everybody is bringing? You should be able to know some basic things about all these things. So if they give you, you can go to your, at least with this knowledge, there's no way you want to calculate for a liter, you will not know the amount of with the amount of reinforcement that you will need. You don't need to panic. Maybe they said we don't have 32 mm diameter bar in the market. You don't need to panic. This course will let you know, okay, the possibility of using another reinforcement size and what are the numbers that you need to provide. All the loadings on your structure, how will you know, okay, maybe this structure is not being abused? If you don't understand the loading condition, how it is being loaded, how you'll be able to distribute the load on each of those members. I hope you understand. You are the designer. You should have the knowledge of what everybody is doing, both the structural engineer, the builder, and every other architect. You should have the knowledge. Are you getting me? So that's why I have to just put you this. I can't just, if you just carry some calculation and just give you some solutions, I'm not helping you. That's the truth.
So you're not giving us solutions.
You said?
Sir,
Okay, Jadi.
I'm actually saying that.
So this formula, how do we tend to go about it, sir?
This particular formula, this number 1, number 2, number 3, you should have it at the back of your mind. 1, 2,
1, 2, 3. We should know that one.
If you on this one is, you don't need to open textbook before you know this. You must know it. You understand? These 3.
Okay.
So once you know these 3, any other one that might be difficult, I will have to make provision for it.
Okay, provide the other one for us in case you need to use, right?
Yes. Now I want us to look at this example before time will run out. Even look at the number of people let me say, in the meeting is negligible, almost 6 or so. And you can see, I don't know, we are just 8 in numbers here. So you can see how serious your class is. And you are expecting area of concentration. Me, I'm not giving area of concentration. I will do calculation for you. If you like, concentrate. If you like, don't concentrate. So let us look at this, Gary.
I think
Let's say we are given a beam like this. We want to look at the number of reinforcement that is needed. This beam section you have here, we have the FCU to be 30, you have the FY to be this, and you want to design ultimate limit state, the design moment ultimate limit state, that is your M, is this. So what do we need to do? We want to look at the tension reinforcement that is needed. And how do we go about it? I told you the first thing is that you calculate this your K value, which is M over BD square FCU. When you calculate it, whatever value you have here, you will cross-check whether it is less than 0.156. If it is less than 0.156, then you will know that, okay, you don't need compression reinforcement. That is, it should be singly reinforced. Now, this Z value, which is the formula that I told you that D into 0.5 plus square root of 0.25 minus K over 0.9, this formula, this one. Now, you see this Z value. How did they arrive at it? Look at this chart we have here. You can see from here to here.
So please, how did we arrive at the value of M?
M is your maximum moment. If you have a simply supported beam, any beam you have, are you getting me?
Yes, sir.
Let's say you have a beam and it's not loaded initially. You can calculate the weight of the beam, right?
No.
I explained to you in the first lecture now how you can calculate the weight of a beam. Before we went on break, I told you how to calculate the weight of a beam. That means you didn't attend the first segment.
No, sir, we've been here since, but we didn't recall that.
That's
You
the
can't recall
first.
it.
That's the first explanation I did, and I even wrote some things on the board.
Left hand.
So if you know how to calculate that weight, definitely you know how to. And I explained to you how you calculate from here, how you get your moment based on this for this lintel. So if I told you how to calculate this, and from here, how we arrive at this moment here, I believe others will be easy for you. So that particular procedure that I explained to you, in a situation whereby, let's say, though I don't think that condition will come up in your exam, but in a situation whereby you're on site and you need to calculate the weight of this beam, that's the procedure you follow. And you will know how you can get the maximum bending moment. For a simply supported, you can say WS square over 8, which is always the general case. But that W, if you don't know how to calculate that W, you are wasting your time. That is the first thing I told you, 1.4 GK plus 1.6 QK. You have to know how to calculate that particular one.
All right, sir. We'll go with it.
Somebody is asking a question. Okay, now for this particular one, I said we calculate our K. For here, we have K to be 0.1. What is the next thing after K? Is our Z value. And I told you that this Z value, it ranges from 0.775 to 0.95. The maximum value is 0.95D. So when you calculate it, whatever value you calculate in that your Z, in this your Z formula, whatever you calculate, you check, is it greater than 0.95? This table you are seeing here is just a series of Z over D, and it's range from this to this. You understand? Maybe if I have 0.1, I just use Z to be. They got it from that formula. Now, when you calculate it, your Z value is this 426 millimeter. After getting your Z value, you just calculate your area of reinforcement, which is your AS, and your M given here is this. Just put it divided by 0.95 FYZ. FY is your Z value is what you have here. This 10 raised to the power of 6. Why are we putting it? Eyoza, you are writing on my screen. Eyoza, can you erase what you wrote on my screen? Okay, and let's look at it this way. Your AS equals to M over 0.95 FYZ. You just put the value of this, you put it here, and I told you this one is times 10 raised to the power of 6. Why? Because we are converting kilonewton to newton and meter to millimeter. This our FY is in Newton per mm square. We cannot be working with Newton per mm square and be using this one to do our calculation. They have to be in the same unit. And it is easier for us to turn this one to Newton millimeter than working with kilonewton meter. So once you arrive at this value, which is from this calculation, you have this, then you look at your table. Your table for your steel reinforcement, this table, we want to use 25 mm diameter bar. How many 25 mm diameter bar will I have in 886? 25 mm diameter bar in 886. 886 is between this and this. So I can provide this because this is higher than 886 millimeter. That's better. We have 886. We come to our 8110, our steel manual. Then we provide a value under 25 mm bar. And this is we don't have 886 here. It's in between these two. So we provide the next one, which is this 982. This 982 is what we're now saying the new area is 982. Even though this is the AS calculated, this is the AS provided. Now, the there's what we call the minimum reinforcement that is needed and the maximum amount of reinforcement. When you are dealing with IUCO, the minimum amount of reinforcement is 0.13% of BH, and the maximum is this. Are you getting me? Your reinforcement should be in between these two. So how do you do that? You calculate 100 AS over BH. 100 times this divided by B. Your B is 230. Your B is 230. Your H is 550. 230 times 550. So you have 0.78. Now this 0.78, it is greater than this and it is lesser than this. So if it is in between, that means we are okay. But if this 0.7, if we have at something like 4.8, that means we are over designing. So our calculation is wrong. That is just all about this one. I don't need to waste my time on this. It's very simple. Any question on that? Any question on that? Question?
Yes, sir.
Okay.
What we're trying to talk about was for coming, sir. Hello.
Go ahead, I'm listening to you, please.
Yes, sir. Yes, sir.
Yeah, you want to check it out.
You want to check?
You want to check it out. You want to check the question out.
Sir.
I'm with you.
Possible to like them allowed.
Sorry, I wanted to ask. Can you hear me, sir?
I can hear you, yes.
So, like, apart from calculations, are there any like theory things inside this handout?
Yes, I will add some theory to it.
Like
Go, mama. Go, mama.
Sir?
I will add some theory to it.
My God.
But I always like theory to be on its own and calculation to be on its own.
Yes, sir. So we are here.
That's all. Any other question?
That's not.
What is other question that you have again?
Sir, so in the last question, that single reinforced rectangular section. So we were wondering the step 5 that says check the area of the steel actually provided with the limits of required code. The one we had like 100 AS over BH is called to 100. Yes. Why didn't we use the one lesser?
No. This one is just to check whether it is within this range. This is the minimum area of reinforcement that you need for your construction, and this is the maximum area of reinforcement you will need.
No, I'm talking about the new area we got.
Yes, that 982.
That 982.
Why didn't we use 491, Abi?
Yes, why didn't we use 491?
Okay, it's just like we are saying you are in higher institution. You entered in Jabu in 2022, and maybe you are in 300 level now. How will you feel if you are taught 200 level course and you are being asked questions of 400 level students? What will happen?
I'll feel hot.
The same thing, the structure too will fail. The same way the student will fail, the structure too will fail. If you are under designing, the structure will fail. If you are over reinforcing, there won't be enough concrete in the structure, and the structure too will still fail.
So because provided the two the T25 bar. The T25 bar. Is it the one in the question? The rectangular bar.
The T25 bar is no. The question doesn't have this one. No, it is, hello. The question doesn't have this one. It is what I'm providing that we are putting here now. The question will not have that. The question will just come in this form. this, and then we have this section, D and H. You just be given, that's all.
Okay. Because
So,
That's
sir,
if-
this
that's
diagram is
if-
going to be given to us with the dimensions.
That is if this one is coming out.
as if it's coming out, will it be given to us with the dimensions?
If I want to give you this, I will not give. I will. This is where I will just give you. I will just give you this. I'll give you
just the diagram and
I'll just give you the diagram like this. If I want to, I'll give you the diagram, and I will not give you. I won't even give you this one, and I'll give you this one.
Sir, where will we not get the depth?
Okay, sir.
Because you can calculate the depth.
Let's give us question. Let's go and solve that.
Please, sir, we have exam by 1. If you can just help us and give us the question that will come out.
Are you saying you cannot calculate D when you have your age?
That we will get this D now. It's going to stress us. So
how is it going to stress you? Because I have given you the formula, and Ogeshi, or what's her name, that lady last week, she even said, is this one constant? And I said, as far as beam is concerned, it is constant. E equals to H minus over minus link minus half of the diameter bar. I think that's what I told us. And you can always see it here. It's very simple. Once you know your cover, and if you're not giving cover, use 25 mm, which I have told you already. Whatever diameter of bar you are using, I've told you the minimum length that is needed, which is 8. What else do you need again?
Okay,
Sir.
There's one more thing.
I'm with you.
Okay, sir. Sir, we're not asking you for your question.
Ask your question now.
No, we're not asking you for your
Sir,
question. We just want guidance. Like, okay, you have 5 questions. Number 1 is compulsory, and then this is where you should read for.
I don't have compulsory question. Point of correction.
No compulsory questions.
No compulsory question, yes.
Okay, so like, okay, number 1, just know.
Okay, sir.
Yes,
The PDF is too wide.
Like, number 1, we are reading singly reinforcement beam. So that one now we know that number 1 we are reading singly. So go and learn singly very well.
I can't tell you what will come out. I will only guide you.
Sir, you don't want us to fail.
I can't tell you what will come out. I will only guide you. If you see something like that, I can only tell you this is what you should do when you have this kind of scenario. I can't tell you this is what will come out. And if I will ask you double reinforce, then I will give you this formula.
sir, in this kind of
Sir,
an average PDF we are reading for this semester is 55. So imagine we have like 940 pages to read for this exam. It's not fair.
It's not fair.
Everything
Sir.
of
And we are going to do calculations, put formulas that we don't know where it's coming from.
so the last time we did something of such, it was not a nice exam.
So when we get to site, we'll learn all this one.
Oh, I told you the calculation is coming from this textbook now, this BSS 110. And I've shown you
Exactly.
where it
So
is.
this textbook you just moved to now. We got some values here that we are using in our calculation.
The only thing, even this table, I've explained to you how to calculate your area of reinforcement if you don't have this.
Yes, I understand this one. I understand how to use this.
There's nothing you need that I have not provided for you. It's just the only problem you're having is just that you are just scared of nothing.
Sir, it's not nothing. Structures should not structure us inside the exam.
So it's very simple. It's very simple. If you attended all my classes, and even this morning, if you did the tutorial, that one will even refresh you on what I have taught already. So I don't think you should have any problem.
So what are they calling it? Because when we go
This morning
Sir,
now.
please wait here. Oh my God. Sir, please, can we go to page 20? Please.
Okay.
Just one question there.
Okay.
The,
We are here. We are there already. I'm there
Yes.
already.
Hello?
Hello.
Sir, can you hear me?
I can hear you, yes.
Yes, sir. So you know this place say provide 2 C25 bars, So after our calculation, we have finished. We must always say provide 2 T25 bars because I saw that it's not changing. Is
Provide
it the area that
2T25.
changed?
See, provide 2T. You must always provide what after calculating this. You must provide. It's compulsory for you to provide. Are you getting me? And this one is not compulsory that it is T25. You can use T20. Are you getting me? But why this placing is
That's the part I don't understand. Because how did 25 reach here now?
See, area of reinforcement. See, the most important one is
for
this.
the diagram, but then it's not giving us the area of reinforcement.
See, hello.
Oh, God.
Hello, are you getting me?
Yes, sir.
This one,
No, I'm not getting
this
it,
one,
sir.
it is after getting this that they are putting this here. This one will not be in any question. This is what you are calculating for. This is what you are looking for in your beam that you want to design. You don't know the number that you will need. Now it is after doing the calculation here that you arrive at this. When you arrive at this, and I told you that you have 886, that is the area of reinforcement you need. Now you now come to this table. Look at this table. As big as it is, we have 6, 8, 10, 12, 16, 20, 25, 32, 40 bars. These are different bar sizes that you have in the market. Now, from all of them, it is not possible for everybody to say, I'm using 20 Somebody might say, I want to use 25 Someone might say, I want to use 32 Now, if you are using 20 based on our calculation, how many number of bars do you think you will need? Because our calculation, we have AS to be 886. So how many do you think you will need under 20 bar now?
We need 3 number of bars.
Under 20 bars, how many numbers do I need? Please, 1 number, 2 number, 3 number, 4 number, like that.
Is 2 number of bar.
Y20 now.
Okay, we are using Y20 to be 3.
3 numbers of bar.
We are using under 20 diameter bar. How many are we going to use?
3.
So if I'm using 3 now, the area of 3 is now 943. Now, what do you think I will provide here? I'm going to provide 3 T20 bars.
Can you
hear me?
Oh, Father. What
Yes,
can you hear me, please?
Yes, sir.
Under 20 diameter bar, you have 943 which is higher than 886. Now, this 943 square, it is 3 number of T20. Now, here, I'm going to say provide 3 T20 bars. Area equals to,
I think this thing is that this
area equals to 943 square. 943 square. That's what I will have here. My time is running out.
Wait.
Down to this list.
I'm with you.
That's just one.
Sir,
I'm with
you know
you.
my company. I don't. God, I beg.
You said?
I understand how you. No, I don't understand. I will not lie.
Which one is it that you say you don't understand?
This line, after we got 886, so where are we?
Can you see my screen, please?
Our AS is equal to 886 meter.
Yes. When our AS is this, are you getting me?
Yes, sir. Then
now, how many? We're going to say, okay, this is the number of bars we need to provide. Under this, we look at 25. 491 is for a unit number. And the area we're looking for is 886, which is in between these two. I said we'll provide the next one, which is this 982. If I'm using 25 diameter bar, that's why we have 982 here. This is 982, this is 982 here. But if you are using 20 diameter bar, you are going to provide 943 as against this.
So is it our choice, or if we are supposed to wait? What's going on? Am I the one choosing it? Like, will I say, okay, provide T20 bars, then I'll now say T area is equal to this.
Yes, you are the one that is providing
so
this.
You
are the one providing this because this is the only thing that anybody will calculate out. You are the one that will not say, I'm recommending this for anybody. And what you are recommending
so
should be
if
higher
provide
than this.
325 now, it's like a recommendation. I'll write recommendation. Dot provide 2, or if it's this 25 I'm using, I'll say wait. If it's this 20 I'm using, I'll say 3. If it's this 25 I'm using, I'll say 2. Is that it?
If it is 20, if it's 20 diameter bar, you say provide 3 T20 bars. If it is 60 that is in between these two, I will say provide 5 T16 bars. Area equals to 1010. If it is under 12 bars, 12 bars, 886 under 12 bars is in between these two. I will say provide 8 T12 bars, and the area will now be 905 for 12 bars. Instead of 982, it will be 905. It's very simple. This thing is a simple something it's very simple to look at. This is the easiest thing to look at.
But we are the one choosing the bar we want to use.
You are the one that is providing it based on what you have in this area. You are the one that is providing this, and your provision will be based on this bar size. And I told you, I explained to you how to calculate this one for a unit number. I explained to you this one per R square. How they got this one?
Yes, in class that day.
So what else do you need again?
Sir, wait. You know that this calculation is not finished. Now they say that for the still provided, they not started calculating and that thing. Where are we going?
So, okay. Now, when you say you are recommending this,
100 ASBH.
How do you know whether your area of reinforcement is in this range? This is the minimum area of reinforcement you need. This is the maximum area of reinforcement you need.
I did not hear you since. Please, let's go back to this 100 AS.
Wait. Wait, please. Oh, sir, I wanted to ask. This, the provided 2 bars that we have here, this 25 bar that we are using, are we the one choosing?
How many times you want to tell you? You are the one that is providing it now. You, after calculating this one, you come to this table here. You look at it. Am I providing under 20 diameter bar? If it is 20 diameter bar, 886. I will look for 886. 886 is in between these two. I cannot choose something that is lesser, so I provide this one. And this is how many number of bars? Is 3. So I say I provide 3 T20 bars. And the area is equal to, the area will be 943 squared. So what is added in that one?
All right, sir. Right on, sir.
Right on. You calculate 100 AS. For this particular case now, it will be 100 times 943 divided by 230 times 550.
Wait. Sir, hold on.
I'm holding on.
What are we trying to do now? We are trying to find AS again.
We want to look. No. We are trying to look whether it is in between this one and this one. So whatever value we get here, this value, we will check. Is it greater than this? Is it lesser than this? If it is less than this, that means you are under reinforcing.
Sir, this value, this 0.13 and this 4.0, are they constant that we will always put our 100 AS over BH?
By God's grace, that is a constant. That's the, if you look at your notes, that is what we have here. This provision we have here.
Okay, sorry again. This 230 and 550.
Yes.
Where is it?
Let me just bring out something here.
This well.
Yes, look at this. Minimum area of reinforcement. Can you see it? 0.13, 0.24. Can you see it now? That's the minimum. The maximum area, that's what we have there. And the maximum area depends on whether it's rectangular or this thing, which is 4 and 6. I told you that it's in your notes. This one is your note. You can see it. Then,
Is it part of the question? Or we should just know it?
if you how are you going to tell somebody that what you have provided is okay? How are you going to tell somebody that what you have provided is okay? That is, let's say, it will not fail. Yes. You can see this. You can see this. All these values, you have been told from the beginning. All these things are very simple. There's nothing in all these notes. Everything is what I've explained. We have explained almost everything. Even today, we have said everything today now. All the calculations have been done today. The one that I wanted to show you, lest I forget, for single reinforced. I think I've explained this in class to you. This formula. I don't know whether this one is me or this thing, but just know it in case. Just know how to calculate this. This is simpler more than by Asia. All you just need to do is you are given this. I've explained this in class. Yes, you are given this. Then you calculate. This is your U or your N. This is your area of column, 300 by 300. This FCU, this FY. So we have 0.4 FCU BH plus AS into 0.8 FY minus 0.4 FCU. This B is 300. This H is 300 for this particular case. So ASC is what you are looking for. Area of reinforcement is what you are looking for here. So, but that is substitute other values. This is the only one that you are looking for. And then if you come out here, then you have the area. So the same thing applicable when you have this area. You are going to look at this side area of bars again. We have 1741, which is in between this and this, 1741. So I cannot provide this one because this one is lesser than 1741. So I provide this one. So I will say provide 4025. 4025. And the area is 1960. Is it not too simple for 300 level students?